Welcome to Chapter 8, Section 8.1. We're going to discuss concentrations and dilutions. First, looking at a concentrate, it's going to be a highly condensed drug product, and it's most often going to be diluted prior to dispensing or administering. And the dilution is going to be the product obtained when an inactive ingredient or the diluent is added to a concentrate. Now, important to keep in mind, medications can be diluted for several different reasons. Sometimes they're diluted prior to administration to children, infants, and in older adults. They also may be diluted so they can be measured more accurately. The rule of thumb for pharmacies is that the required dose should have a volume greater than 0.1 milliliters and less than 1 milliliters. It's going to be easiest when we're looking at these to solve, typically with the ratio proportion method. And you can see on the marker board that this is typically a two-part process. The first part is going to use the ratio proportion method to solve for the volume of the final product, and it's going to do that by using a ratio of diluted solution to desired concentration. And that's really important to keep in mind when you're reading through the story problem. The second part is going to determine the amount of diluent by subtracting the concentrate from the total volume. Okay, so let's open our books to page 202, and we're going to look at example 8.1.1. Now keep in mind the two steps that you see on the marker board. Sometimes it's helpful to write them down or to make a little note to yourself so you remember how the process is going to work. But let's look at example 8.1.1. Dexamethasone is available as a 4 milligram per ml preparation. An infant is to receive 0.35 milligrams. Prepare a dilution so that the final concentration is 1 milligram per milliliter. How much diluent will you need if the original product is in a 1 milliliter vial and you dilute the entire vial? Okay, so the first part, we need to determine the volume in milliliters of the final product. And since the strength of the dexamethasone is 4 milligrams per milliliter, a 1 ml vial is going to contain 4 milligrams of the active ingredient. You can set the proportion up. We know we're looking for milliliters. We're looking for volume. And the vial is going to contain 4 milligrams and 1 milliliter per 1 milligram. And we're just going to solve for X. Four divided by 1, so X is going to equal 4 milliliters. So now that we know what the total volume is, we already know that it's 4 milliliters, and we know that the concentrate is going to be 1 milliliter. We know that we need 3 milliliters of diluent. Okay. Let's look at example 8.1.2. You're instructed to make 1,000 milliliters of a 0.8% weight and volume solution. You have a stock concentrate of 95% weight and volume. How much of the concentrate will you use and how much diluent will be needed? So first part, we need to determine how many grams there's going to be in the final product so we can determine the strength of the solution. So we know we're going to be solving for grams. So our desired grams is going to be our X. The desired volume is going to be 1,000 milliliters. And we know that it's a 0.8%, so that's going to be 0.8 grams. And it's weight and volume, so weight and volume, we know this is going to be milliliters over 100 milliliters. And we can solve for X. And X is going to equal 8 grams, because remember this is our unit of measure. Now we need to determine how much of the 95% weight and volume concentrate will be required to provide the desired number of grams. So now that we know our grams, we're going to be solving for volume. And since it's 95% weight and volume, typically you would have the weight on the top, but since we're solving for milliliters, we're going to just flip it, and it's 95%, so 95 grams over 100 milliliters. Now we can solve for X. So X is going to equal 8.42, and that's milliliters, and so we know that that's our concentrate. So now we are going to be able to determine what our diluent is. We know our total volume is 1,000 milliliters minus our concentrate, 8.42. So that comes to 991.58 ml. So we know that's how much diluent we need. So this is our concentrate, this is our diluent. Okay, let's go to the 8.1 practice problems and take a look at a couple of those. And that's going to be on page 206. Okay, let's take a look at number 1. Calculate the amount of concentrate and diluent for each of the following compounds. Round to the 100th place for this problem set. Remember that the amount measured will be approximate due to equipment restraints. Okay, so let's look at number 1. Prepare 3 ml of a 10 milligram per mil phenobarbital solution from a 65 milligram per milliliter stock solution that comes in a 1 ml vial. How much concentrate and how much diluent are needed to obtain the desired final volume. So we already know what our final volume is. It's going to be 3 ml. So we need to find our concentrate and our diluent. So first we're going to solve for milliliters because we need to know, or I'm sorry, milligrams, because we need to know how many grams are going to be in our 3 milliliter vial. It comes 10 milligrams per mil, and our units of measure match up, so we can solve for X. So 30 divided by 1, X is going to equal 30 milligrams. So now that we know how many milligrams we need, we can solve for milliliters. So that's going to be our next proportion. And we know that the stock solution comes 65 milligrams per 1 mil. And this is our grams, and this is what we're solving for, so now we can solve for X. So we're going to take 30 divided by 65, and that is going to give us 0.4615, but we're going to round that to the 100th, so we're going to round that to 0.46, and that's milliliters. So now we know that that's going to be our concentrate. That's how much we're going to have to put into our final volume. We know our final volume is 3 ml minus our concentrate, and that's going to give us 2.54 of a diluent. Okay, and it's just as easy as that. It's just a matter of getting the story problem set up and being able to solve for X.